LaGrange. It's actually LaGrange, not LaGrange. Like the song. I'm from LaGrange College. My project is on the heating and cooling of the LaGrange College Science Building. My research advisor is Dr. John Ernstberger. We started this October 2010, so not that long ago. We did it for no credit, so I just did it. It's kind of independent. So sit back and enjoy. Okay. So you scroll the outline. We'll start off with our motivation while we're doing this, while we're studying this. Then we'll go to the assumptions for our model. Then we'll talk about the data, how I got the data, and what I did with it. Then our model, and then our numerical solution, our heating, ventilating, and air conditioning system, our results, and conclusion. So our motivation. So the reality of it is that the world's population is increasing, and logically speaking, that means that we're going to be using more resources. And fortunately, people are starting to notice that some of these natural resources are starting to dwindle pretty quickly, especially because the population is growing so rapidly. And also, in a more localized sense, in the U.S., our economy is kind of down right now. I don't know if anybody's noticed. So there's been increased attention put on trying to cut down on energy consumption, and most importantly, greenhouse gases. Okay. So some of our goals. So the reason that I approached Dr. Ernstberger to do this project is because I'm a senior and I'll be graduating and going to graduate school next year. So I wanted to become a better researcher and programmer. So this helped me in both of those regards, even in the short term that I worked on this. And also, in a more localized sense, again, we want to make a better heating and cooling setting for our college. Okay, so these next couple of slides, we had a hired consultant come and give recommendations to the college on different ways we can do better about greenhouse gas emissions and energy. As you can see here, from the natural gas and the purchase electricity, most of our energy, our greenhouse gas emissions come from these things. And as you can tell from the title, from my title, is that our air conditioning and our heating are going to be in this range. So if we can cut down on that energy consumption there, then that could greatly decrease how much is being used in this portion of our gas. Beautiful graph. Okay, so I don't want to scare you a little bit. I'm going to scare you a little bit, but just know that we don't have any hyperbolic time chambers or time traveling devices. This is straight electricity and energy that we're using here. So I didn't get to go back a little bit to show you. This is our beautiful science building here. It's not nearly as it's not really that big, but it packs a punch. So let me go back here. All right, so as you can see here, we used about over $49,000 in energy, okay, just in our science building, okay. So what our goal is to try to create a model so that we can cut down on that. And then if we can make a model for our science building, okay, and sorry about the spelling, I think our hired consultant for that spell check. What we can do is create a similar model for the rest of these buildings, okay, and then on the whole save our college some money and energy. So some of our assumptions, okay. One is that for our model for this project it's going to be a uniform and undivided space, okay. So it's a box, okay. You can't get out, all right. We don't take into consideration windows and doors and things of that nature. So, and also we presume what our HVAC is going to be growing at as far as the air conditioning and the heating. So I want to emphasize that this is a very simple model. Okay, we haven't had a lot of time to work on it, so it's very simple, but it's really cool. So our data. So it's kind of interesting. So back in October when I approached Dr. Ernstberger, he was like, well, we need, in order to model an inside temperature, we need to find, we need the outside temperature, okay, for either LaGrange or the closest metro area was Atlanta, which is about an hour north of us. So, so what I did was I called up these weather stations, and not only are they, it's hard for them to predict the weather, but it's hard for them to give me information. So they gave me the runaround. I was looking, but fortunately at my school it's a small liberal arts college, so we have these things called cultural enrichments. And what they do is exactly that. They will enrich you culturally, whether it be with politics or with different countries or something like that. And one of the main topics is sustainability. So I went to a cultural enrichment on climate change, which was just before I had to have my data in. So I went to talk to a man named Deke Arndt. He's from the National Climatic Data Center, and he gave me all the information I needed. We exchanged emails, and he sent me a spreadsheet, and it was awesome. And I'm really thankful to them for that. So what he did, he gave me the temperatures for the Atlanta metro area for the year 2009. Okay, you kind of see here. This is by the hour the temperatures in Fahrenheit that he sent to me. But unfortunately, there were a couple problems with it. There's a lot of things that they need that I didn't need. So what I needed was the time, the day, and the temperature. Unfortunately, they had things like frequency and location, things of that nature, but I didn't need any of that. So what I did was using Excel and MATLAB, I got the things that I needed, and then made it more usable. So when he gave it to me, it was kind of weird. So what I did using MATLAB's floor and mod functions, what I did was it started at like 52 minutes for the day, then it went to like an hour and 12 minutes, then it went to like 2 hours and 52 minutes. So it was kind of erratic. So what I did was I made those regular. Okay, and as you can see, I got it to 4 significant digits because it got down to the second. Okay, so for January 2nd, 2009, it would be 1.5000. So that would be the day, part of the day. Okay, so as I said, this is going to be, it was in the regular time steps, okay, but I needed a solution, okay, so what I did with MATLAB, I used the spline function, and what that does is that it makes a smooth curve, okay, through all my data points, so I'll be able to, get some points that I needed, okay, you'll understand why I used the spline function in 5 seconds, okay, so my model was Newton's law of cooling, very simple model. Big T of T is the internal temperature at time T, and big A of T is the external temperature at time T, and our variable K is the coefficient of the physical apparatus, which is our building. Okay, and so in order to solve this model, what we used was Euler's method. Okay, and remember I said that it was sporadic, and then I used the spline to make that curve. And so what I did was to make regular time steps, okay, I used that spline function to pick regular time steps from that spline function, okay, if that makes sense, okay? Okay, so here are a couple pictures here. So, so here's our results without our controller, okay, so this is the inside temperature off against the outside temperature here, and you can kind of see how it stays in between there, okay? And so I want you to, so this is a blown up picture of day 20 through 70, okay? And you can kind of see as and this is very fortunate for us, right? Because when we're inside, we don't want to, be freezing outside, even without temperature. So you can kind of see, even as the outside temperature is sporadically moving, that our inside temperature is still kind of staying the same, which is like we're